Review on performance analysis of steel concrete composite section. Abstract buildings in high-seismic areas must be designed with particular attention to their lateral stability during extreme earthquakes. Nonlinear phenomena in structural mechanics such as nonlinear material behavior, large deformations, or contact problems have become standard modeling tasks. Because of a rapid development in the hardware sector resulting in more and more powerful processors together with decreasing costs of memory, it is nowadays possible to perform simulations even for models with millions of degrees of freedom. In a mathematical sense, the finite element solution always just gives one an approximate numerical solution of the considered problem. Sometimes it is not always an easy task for an engineer to decide whether the obtained solution is a good or a bad one. If experimental or analytical results are available, it is easily possible to verify any finite element result. However, to predict any structural behavior in a reliable way without experiments, every user of a finite element package should have a certain background about the finite element method in general. In addition, he should have fundamental knowledge about the applied software to be able to judge the appropriateness of the chosen elements and algorithms. Keyword, FEM, Composite, RCC. Introduction. The use of composite structures is increasingly present in civil construction works. Steel concrete composite beams, particularly, are structures consisting of two materials, a steel section located mainly in the tension region and a concrete section, located in the compression cross-sectional area, both connected by metal devices known as shear connectors. One type of these connectors is called head studs, as the main functions of these studs are to allow for the joint behavior of the beam slab, to restrict longitudinal slipping and uplifting at the element's interface, and to take shear forces. Double steel concrete composite continuous beam is a new structural system developed on the basis of single steel concrete 1, in which there is also a bottom reinforced concrete slab connected to a steel profile in the negative moment regions through the head studs, therefore with two interfaces. Comparing with the traditional single steel concrete composite continuous beam, its advantage is that effectively limits the crack width of the negative moment area, and also improves the stress state of section, so that it is suitable to the composite continuous beam with a larger span. The mechanical properties of the double composite beam obviously depend on their respective properties and interactions. In the negative applied bending moment area, the concrete slab cracks under tension and then the interface slip occurs between steel profile and concrete slab. With nonlinear features, it makes great impact on the structure of the internal forces and deformation. Therefore, it is necessary to present a finite element model to study the mechanical properties of the double steel concrete composite beam in negative moment regions. 2. State of development. Qingchuan Liang et al. 2005. The verified finite element model is then employed to quantify the contributions of the concrete slab and composite action to the moment and shear capacities of composite beams. The effect of the degree of shear connection on the vertical shear strength of deep composite beams loaded in shear is studied. Design models for vertical shear strength including contributions from the concrete slab and composite action and for the ultimate moment shear interaction is proposed for the design of simply supported composite beams in combined bending and shear. The proposed design models provide a consistent and economical design procedure for simply supported composite beams. Atif M. Abdelhafez et al. 2012. This paper presents the behavior of simply supported concrete steel composite beams with corrugated web under vertical loads using the commercial finite element, FE, software NC. The three-dimensional, FE, model is used to simulate the overall flexural and shear behavior of simply supported composite beams with corrugated web subjected to vertical loads. This study covers load deflection behavior and load strain curve. The reliability of the model is demonstrated by comparison with experimental results test carried out by author and others. Two identical composite beams with corrugated web were tested to failure under vertical loads. The comparison shows good agreement. A parametric study was undertaken using the validated model performed using finite element program. The parametric analysis was executed to study the effect of web thickness on the behavior of concrete steel composite beam under vertical loads. David Leaf and Jeffrey A. Lehman, 2013. This paper presents laboratory test results and analyzes the ultimate flexural strength of the tested composite beams using currently available methods and compares to observed behavior. Additionally, simplified finite element models of the composite beam were developed with results also compared to the data obtained from the tests. Based on the results of these analyses, recommendations for design are made that allow accurate determination of composite beam flexural strength. Shweta A. Wak, and Dr. U.P. Waga, 2014. The use of steel in construction industry is very low in India compared to many developing countries. There is a great potential for increasing the volume of steel in construction, especially in the current development needs India, and not using steel as an alternative construction material and not using it where it is economical is a heavy loss for the country. In this paper, study of 4 various multi-storied commercial buildings, i.e. G+12, G+16, G+20, G+24 are analyzed by using StudPro software, where design and cost estimation is carried out using MS Excel programming, and from obtained result comparison can be made between R.C.C and composite structure. Dr. D.R. Panchal, 2014, in the present work, a simplified method of composite slabs, beams, and columns design is used and software is developed with pre- and post-processing facilities in VB.NET. All principal design checks are incorporated in the software. The full and partial shear connection and the requirement for transverse reinforcement are also considered. To facilitate direct selection of steel section, a database is prepared and is available at the back end with the properties of all standard steel sections. Screenshots are included in the paper to illustrate the method employed for selecting the appropriate section and shear connectors and thus to verify the design adequacy. E. Habelabadi and Ben Young, 2014, this paper presents an investigation on behavior and design of composite beams with stiffened and unstiffened web openings. The composite beams were simply supported and had profiled steel sheeting oriented transversely to the steel beams. Nonlinear 3D finite element models were developed to analyze the inelastic behavior of composite beam components comprising the steel beam, concrete slab, profiled steel sheeting, headed stud shear connectors, reinforcement bars as well as interfaces among these components. In addition, the load slip characteristic of the headed stud shear connectors in composite slabs with profiled steel sheeting were carefully incorporated into the finite element models. The finite element models of the composite beams have been validated against published experimental results. Professor Vijay S. Savant et.al. 2015, in present study, literature work of comparison of steel and concrete composite building framework by different researchers in seismic performance. The composite connections are considered in all 4 cases, as beam in RCC to column in steel, column in RCC to beam in steel, beam and column both in RCC and also both in steel. Equivalent static method and response spectrum method will be used for analysis. Also same modules compared on SAP 2000 software. Cost effectiveness based on material cost for all types of building frames will be determined. Comparative study concludes that the composite frames will be best suited among all the 4 types of constructions in terms of material cost benefit added with better seismic behavior. Unju.T and Smitha. K. 2015. Composite structures consisting of concrete slab and rolled up steel sections are widely used structural members in bridges and high-rise buildings. The composite action is established by connecting the concrete slab and the steel section by using shear connectors. In this paper, 4 different types of shear connectors have been analyzed and the best connector for a particular composite beam has been evaluated based on its performance under static load, keeping the loading and the amount of steel in the connector as a common aspect. Lee Ziawan et.al. 2015, the paper is devoted to the behavior of steel concrete beam with hybrid full web and truss system subjected to 4-point loading mode. Steel concrete composite beam with HFWT system was investigated both experimental and computational using finite element technique. In the finite element analysis, test specimens was modeled using finite element software Abacus and a nonlinear analysis was performed. A large amount of finite element models were built. The effects of the shear span ratio, the angle A between lateral truss plane and vertical plane in cross section, the angle B between inclined truss and vertical plane and longitudinal plane were reported. A shear strength equation that considers the shear contribution of the concrete flange and the shear strength provided by the web of the steel beam and inclined truss system is proposed. Richard Franz et.al. 2017. Nowadays, castellated beam becomes popular in building structural as beam members. This is due to several advantages of castellated beam, such as increased depth without any additional mass, passing the underfloor service ducts without changing of story elevation. However, the presence of holes can develop various local effects such as local buckling, lateral torsional buckling, caused by compression force at the flange section of the steel beam. Many studies have investigated the failure mechanism of castellated beam, and one technique which can prevent the beam fall into local failure is the use of reinforced concrete slab as lateral support on castellated beam, so-called composite castellated beam. Besides of preventing the local failure of castellated beam, the concrete slab can increase the plasticity moment of the composite castellated beam section, which can deliver into increasing the ultimate load of the beam. Taijiang Lu et.al. 2019, This paper evaluates the flexural performance and quantifies the secondary moments in two-span pre-stressed steel concrete composite beams. A nonlinear model capable of simulating the full-range nonlinear behavior of continuous pre-stressed composite beams is validated against experimental results. A parametric numerical investigation is then conducted to examine the effectiveness of strengthening a continuous steel concrete composite beam with external tendons of different cross-section areas. In addition, secondary moments in continuous pre-stressed composite beams having different tendon layouts under symmetrical and unsymmetrical loads are investigated. The results indicate that external pre-stressing not only increases significantly the ultimate load carrying capacity but also improves the moment redistribution ability of continuous steel concrete composite beams. Moreover, the analysis shows that significant secondary moments are present in continuous pre-stressed composite beams throughout the loading history. It is therefore necessary to consider secondary moments in the strength design of this structural typology. 3. Conclusion. This paper focuses only on the literature review of previously published studies. The findings of this study: the composite action is established by connecting the concrete slab and the steel section by using shear connectors. There are different types of shear connectors can be used, and find the best connector for a particular composite beam can be evaluated based on its performance under static load, keeping the loading and the amount of steel in the connector as a common aspect. For further study to analyze behavior of the connections and design parameters of composite members used in composite sections for different configurations under seismic loading conditions.